The human Thistlethwaite algorithm is an interesting technique of solving a Rubik's Cube where you go from, a standard scrambled state all the way through a couple different stages, eventually to reach something that looks like this, where you have a lot of opposite colors. And it doesn't look like the cube is extremely close to being solved at this point, but this is actually the final step. It's a very interesting method of solving the cube, and it was invented by Ryan Heise. It was his attempt at making a human solvable version of the Thistlethwaite algorithm, which is a computer algorithm used to solve the Rubik's Cube that does so by kind of reducing the types of moves needed to solve the cube. So the goal of the solving method is essentially just to mimic the look of that method of the original Thistlethwaite algorithm without actually doing it as efficiently as the computer would. You can still be somewhat efficient with it if you learn a lot of different cases, but I'm going to teach like a very base implementation of it, which kind of looks cool to do. It's not great for speed cubing. It's not great for finger tricks. It's just a really fun method. And I haven't really seen a ton of resources on it. It's a very strange one, and it took me a while to kind of piece together all the resources that I could find in order to kind of get okay at solving it using this method. Now, I will say this is not meant to be just like a beginner's method. So if you don't already know how to solve a cube, I do not recommend this method. It's going to be more confusing than just something that's more standard. So learn something more standard, get okay at it, and then maybe come back if you're interested. But for those of you who are already comfortable solving a cube, a lot of the stuff I'm going to show you should be pretty straightforward. So to start off, this method requires us to orient edges. So if that's not something you're familiar with, I'll break it down. But essentially, an edge is considered a bad edge if you're not able to place it without using a move set that you're not really supposed to. So in our case, the move set that we have is completely normal, except we can only do L2 and R2 moves. So if we cannot place an edge using that move set, and we have to do a single R or an L, that's going to be a bad edge. Now, the way that you can detect them, I'll kind of just run through which ones are bad, because it's kind of, you could figure it out intuitively, but it's a lot easier to just remember if a sticker is in a specific location and it is a specific color, then it is a bad edge. That's kind of the way that I go about it. Now, the easiest ones to spot are anything on the front or the back face that is a red or an orange, assuming we're starting with red on top and white front, which is kind of the way that Ryan Heise originally described this method, I believe. So that's the orientation I'm going with. If you did want to learn it a different way, everything still applies. You're just going to have to kind of figure out which colors correlate to whatever you prefer. But essentially, opposite colors are going to be important here. So at this stage, I mean, just like I was saying, how we're going to get to this stage and like everything is kind of just opposite colors. The entire time we're solving this, we're only really concerned about opposite colors until we get to that stage. So red and orange for me are opposites. So we treat them as one and the same. And the same goes for white and yellow. And right now, we're not really concerned about the colors on the sides. So the main ones to watch out for are those red, orange, yellow, and white faces or stickers. So if we have anything on the front or the back that is red or orange, those are bad. And we're always going to have an even number of bad edges. So these are definitely bad because they're on our front face and they are one of the bad colors. Same with this one in the back. Now that's only 3, and that's because we've really only looked at 2 faces so far. We also want to check the top and the bottom, just like we don't want any red or orange on the white or the yellow face. We also don't want any white or yellow on the red or orange face. And you can see right away we have these 2, which are bad, and we have this one, which is bad. So I think in total that's 6 now. Yeah, so that's 6. Now, we also want to check the sides here, and something to keep in mind as well is you don't want to double count an edge. because as I'm looking around here, I can see when we get to the sides, these are fine and these are fine. So white can be on the top or bottom of the side layers, and red can be in this middle layer. And when I say white or red, I'm obviously talking about the opposites as well. So keep that in mind. But yeah, so these are good. These are good. Now, if we look over here, this one is actually bad on the side because we're in this middle layer and only red is allowed here. So this is actually bad. Now, with that in mind, that puts us at 7 edges, right? So we need to do some double checking here. So bad, so that's 2. Bad, that's 1. So that's at 3. 4, 5, 6, 7. And you see we have double counted actually, right here on top. We counted this as a bad edge, and we also counted this as a bad edge. That is the same edge. So we don't have 7, we actually have 6. I double counted this one. So we have 1, 2, 3, 4, 5, 6. So we have 6 bad edges. And that's something you do have to watch out for. But as you're solving it, you kind of start fixing these as you go, and the double counting issue isn't really a problem if you're actually moving things around in the cube. But that is something to keep in mind. Now, in order to solve these, the only way to really orient them properly is to get them onto one of these sides that are limited to double moves, right? And let's start with this one as an example. So this is a bad edge because no matter what we do, without doing a single turn, we're never going to line this up on that side and be able to place it. So in order to actually convert this to a good edge, we need to turn it once. Now the problem with doing just that is it's going to change all of these, because look, now we have 2 bad edges here that were good edges, right? So it always flips the edges, whether they're good or bad. So the goal is to get 4 bad edges on this side using our limited move set, and then do a single turn to orient them all at the same time. Now, that's fairly straightforward if you're used to just other methods, right? We just need to get 4 of those bad edges we identified over here. So we already have 1. We have this one as well. So we can do a double turn and then bring that over here on the bottom. So now we have, you can see this is not good. This is not good. We have 2. And then we have these 2 back here that I guess we could bring over, right? So this one we can flip around here. So now we have this in the back. We have these still, and we have this one on top we need to get over to the side. And what we can actually do is put that here and then bring this one down. And now we have this, which cannot be in this layer, so that's a bad edge. We have that in the back, which is bad. This is bad on the side, on the top here. And this one is also bad on the bottom. So we have 4 bad edges there. Now, if we turn it and we double check, look at this. I mean, that's a good edge. That pairs up. This is allowed here. No red in the back, no red in the front, and no white or yellow on the bottom. So those are all good edges now. That's great. Now, the problem is we have 2 left that are bad. And if we were to put them over here and turn it, we'll fix 2, but we'll also mess up 2, right? So there's a way to get around that. So first of all, let's find where our bad edges ended up. So we have this one on top. That one stands out. And then we also have, did I miss one? Yes, this one. So this is also bad because only red is allowed in this middle layer on the sides. So this and this are bad edges. Now, if we put them both over there, like I said, that's not going to work. So the trick is you put one over there, flip it so that this becomes good, but these 3 become bad. And now you have 3 bad here, 1 bad here. Now you have 4 bad edges. So all you have to do is bring this over, get it on that side, and now we can see this is bad, this is bad, this is bad, this is bad. We turn that. We now have all of our edges set up to be good edges. And it's always worth double checking if you're not super comfortable with this method yet. So on top, we don't have any of the white or yellow. Same goes for the bottom. On the front and the back, there's no red or orange. And then here, we don't have any whites. And here, we don't have any reds. Here, we don't have any whites. And here, we don't have any reds. So it looks like all of our edges are good, and we're good to move on to the next step. Now, the next step is essentially getting a cross on the top and bottom, but it doesn't have to be a perfect, match in color. It just needs to be one of the opposite colors. And that's what's kind of interesting about this method. So if we wanted to make the cross on top right now, I can see that if we turned this, and then we make sure we're not going to mess up something on the bottom, which we would, let's fix that. So basically this back slot now doesn't have any of our edge pieces. That allows us to then turn this up. And that actually did end up solving this. But you can end up with cases, and I just did the bad thing. You're not supposed to use one turn here. So it's a little awkward. You kind of need to do that on the front. That's why I said it's not great with finger tricks. You could learn the method where maybe the front and the back are the two turned ones, but it's really not a speed method. But anyways, if you get to a point where you have most of them solved and you just have a single one here, you just need to go and pop out one of the ones that are already solved, turn to a slot that isn't, and then flip it back, and that should solve it. So this is mostly just intuitive. There's no real algorithms here yet. We're just orienting the edges, and then we build out this cross on top and bottom. So as you can see, we have the opposite colors making a cross on top and bottom. That is completely valid. We don't have to have them all on the correct side just yet. Now, after this, the next thing we want to do is start getting our corners flipped up so that the entire top and bottom face look like this, where we have our entire top and bottom face showing only the opposite colors and nothing else. This blue is bad right now, and obviously these are also bad. So in order to fix that, there's a specific kind of pattern that you can look for, and that is to have one edge kind of facing away on one of the sides and one towards you. Now, there's not a specific algorithm that I use here. There kind of is, but it sort of just depends on the orientation of stuff. Really, the way that I remember it is I get these paired up like this, where one is facing me, one is away, and then I flip the one that's facing me into the top or bottom layer, rotate it to the side that has the other edge, flip it twice to put that other edge where that other one was, and then undo those first two setup moves. And that'll slowly start flipping our edges around the way that they should be. And we can see here, if we bring this over, now we have another one facing us, another one away from us. We can do the same thing where this just flips up into the top or bottom. We flip it over into that same side that this one's in, turn that twice, and then we undo those first two moves. And then that gives us our top and bottom. Now, if you end up with a scenario where you have three edges and, any number really, and you don't have a perfect, this one's facing me, this one's facing away, you're going to end up being able to get two of them to face you. And you just want to go and just do that as if the other one was facing away, and it'll fix it. It's kind of like a parity thing, if you're familiar with parity from larger cubes or whatever, but not necessarily parity, but it's that same kind of idea where it's you don't have a perfect, fit for your algorithm. Just go ahead and kind of do it and get it into a state where it does work. That's the idea. Now, the next step after that, we have these on top and bottom all good, but they're not necessarily correct here in terms of opposite colors. So the idea now is to actually go and solve the corners in terms of just getting them onto their correct side and also into their correct place. So to do that, what I like to do is you can get them into the opposite sides, obviously, by doing these two moves here. And now we're also at the point where we just want to be doing two moves here as well. So now that we have the top and bottom the same color, as long as we only do two moves for the left, the right, the front, and the back, we're not going to mess that up. So the goal is to get all of these edges into at least the right color on top. And they don't have to be like red with red. It could be all orange on top, even though it's red on top. That's fine, as long as they're all paired up to be the same color on top. So in this case, you can just kind of go at it until eventually you get them like this. Now, if you end up with 3, so sometimes you'll end up with like weird ones that are hard to kind of pair up. And what I think about when I get 3, the thing that kind of helps me do it sort of quickly is I get whichever corner doesn't match these 3 into one of these front corners. And then I look on the bottom, and then whatever 3 I have here, I get that one to be kind of opposite from that. And then I just do like an R2. And then from there, you have 2 and 2, 2 and 2, and you're able to just quickly line up, okay, these orange can just go up here, and then we're done. So these are all on top. They're the same color. Now, I did also just kind of inadvertently get them all to line up. But we're also at a point where we can kind of just flip the cube like this and kind of work with like opposite colors either way. So if we look at this side, we can see these are all just kind of not lined up at all. So there's a couple different cases that you can run into with this. And the main one you want to get to, I'll show you in a minute. But if you already have like a bunch solved, essentially the move set you're going to want to do is this like R prime F, R prime B2, R, F prime, R. And if you do that, that will kind of switch around the orientation of these edges. And you can see now the bottom is all messed up, but that's fine. We actually kind of want that. And you can see now we have like a set of like headlights, right? We have these 2 that kind of line up. Now, anytime all of the other ones are kind of out of order and you have 2 exactly on one side that line up, if you hold those to face you and you do that algorithm I just showed you, it will fix all of the edges. Now, any other case, you don't want to have headlights pointed towards you. So, for example, we do something like this, and then let me just flip it and get it into another state. So if we look around, we can see, we have headlights, right? But look at this, there's also headlights on top. We don't want either of these facing us. Put them both into the back, do that same thing I just showed you, and you'll end up in some sort of a case that should have headlights. And we can just double check and there's no other headlights. So if we do that with the headlights facing us, that fixes the corners. So that's kind of the rule, is if you have one pair of headlights on one side, have them face you on top, do that algorithm, you're good. Any other scenario, point all the headlights you can away from you and do the algorithm. And that includes if like one side is solved on the bottom, just arbitrarily pick like whatever you want on the bottom to be your headlights, right? And then put the headlights on top here, do the algorithm. You'll end up in a state that you can then solve pretty easily. Now, there is one other one that you got to watch out for. And that's if you have these all solved here, these all solved here, and you have no headlights, nothing. And you can kind of see if you line them up just right, like they look like they're sort of solved, but they're obviously not, right? Because we have no headlights anywhere, but they're kind of able to make like columns essentially. So if you ever run into that, it's F2, R2, F2, and that'll flip it. And that can also happen if you follow my rule about the headlights that I was talking about before. For some of those cases, you will end up in a state where you will then have to do that one instead of the other algorithm that I showed you. But yeah, so once we're done with that, we're now very, very close to getting to this state, right? Like we're actually not that far off. So the last couple things that we need to do here are we need to fix some of these edges that are just kind of obviously on the wrong sides, right? Because we want everything to be opposite. And this blue, those don't fit in. These don't fit in. This one doesn't fit in. That one doesn't fit in. We have a couple edges here, more than average, I would say, that are kind of just out of place. And we need to get them so that they're on the correct, like opposite side rather than just like over here where you have to do a single turn to solve it. Because the goal is to get it to where everything can be done with our 2 moves. Now, at this point, if you kind of follow what I'm going to do, we're going to mess up the corners a little bit, but that's okay because it will be very easy to fix them after this step because we will have reduced our moves down to those double turns. So what we're looking for here is to have essentially like an edge that doesn't really belong. So something that's not opposite and another one across from each other on the top. And then you want the same on the bottom. Now, right now we have this one and this one. So these are actually already set up. So we have these two across from each other on the bottom that are not correct. And then same on top. We have this one and this one. So in this case, what we want to do is, the way that I think about it is I want to get the ones on top so that they're facing me, almost like the headlights were before, but just, not the headlights, it's these edge pieces now. So we want to get it so the line is kind of pointing at us and the bottom one is kind of going the other direction horizontally. And then you want to do this, just turn the bottom once, flip the middle slice twice, and then move the bottom back. That's literally it. And you'll already see it's looking a lot better. There's still a couple that are off. Just like when we were orienting edges in the beginning, there's always going to be an even number of these that need to be solved. And we're going to solve them in groups of 4. If you end up with a group of 2, which we just did, by the way, so because I think we had 6 and we just solved 4 of them, we now have this one, which is bad, and this one, which is bad, and everything else is looking pretty good. So when I get into this case, what I do is I actually put them both on the same face. And then at that point, it doesn't really matter. I just do that algorithm that I showed you before. And then we have opposites here, and we have this one opposite and this one opposite. So it's not perfectly set up the way that we want, but all we have to do is just do a 2 move and then bring this down to the bottom with a 2 move. And you'll notice at this point, I'm really just doing 2 moves for all of the sides, except if I'm maybe just rotating around the top. But even then, I might just be doing 2 moves at this point because we really have reduced the moves that we need to be able to actually solve it. So we get it to this point where we have this bar and this bar of pieces that need to be solved. So we put this one facing us, we do that algorithm, and we flip it back. And would you look at that? We've got the cube to this state. So we're on the last step, and now it's mostly just kind of intuitive and just playing around trying to solve it, because it's actually fairly easy to just do a bunch of 2 moves at this point and end up solving it. Now, I don't think you're going to do it randomly. You have to be sort of intentional with your moves, but we're at a point where it's going to be very easy to do this essentially intuitively with the help of like a single algorithm that's very, very simple. So the first thing you'll notice is our corners that we had solved before are kind of messed up. And in this case, it's very easy to fix them, right? With just the 2 moves. But you might end up with something like this, where they're kind of like all out of whack and not obviously fixable. But it's, you'll notice these columns from before probably and just go, oh, I just do that same F2, R2, F2 thing that we did before, and then they're solved. And that's exactly what you need to do. So it's mostly intuitive. If you get into that one state where it's like kind of just weird columns and it's a little confusing to do intuitively, you probably just need to do that. And once you get that going, you may or may not already have the centers lined up with them. They could be all kinds of whatever, out of whack. But essentially, you just want to get the centers lined up so that you have corners and centers done, and you're kind of just left with the edges at this point. And at this point, the last algorithm that I'm going to show you is pretty straightforward. It is just U2, L2, U2, L2, U2, L2. It's hard to remember exactly how many times to do each one, but you just kind of spam those until you get to a point where it looks mostly solved again. And really, the way that this works is it's switching these 2 and these 2 edges. So this goes here, and this goes here, this goes here. So you can see here we have these green and these blue, and this is the pattern I look for. With the cube solved, I'm looking for opposite colors in this position, because if I go and do that move set, it will solve them. And now you can actually see we got to like a pretty common case that a lot of layer by layer solvers are going to be familiar with. And we can actually solve this intuitively using this method as well. So just like I said, we can solve this and this. Now, you're going to end up with a case where it might make some sense to just do like some single moves and line stuff up and then put them back. This is one of those cases, because if we want to switch these two and these two with our algorithm, we're also going to switch these two. So all we need to do is get these into this position, which is very easy to do intuitively. We just flip that up, put it here, and we kind of have this weird looking setup now. But if we go and do our algorithm, we get to this point where it's like, oh, okay, we just do that and it's solved. So that's kind of how you're going to end up doing the final stage, is really just kind of messing around and just having fun doing like a bunch of two moves. You can also do the one that I showed you on the right side if you want to. I mean, you could also just flip the cube like that and do it this way. So it's kind of just up to you how you want to go about it. And I mean, obviously, if you get to a case that you already recognize and you have an algorithm for, you could just solve it that way instead of doing it intuitively. But you can do that entire last layer fairly intuitively as long as you just know how to swap these pieces around like this. The rest is, basic just intuition. So that's a general summary of how this algorithm of a method is supposed to work. It's called the human Thistlethwaite algorithm. It's really just an interesting method that just kind of tries to mimic the Thistlethwaite algorithm that computers use. I find it really fun to solve a cube like this. I'm not super fast at it. I don't think it's something that most people would strive to get very fast at. It's just kind of a fun method, and it just teaches you some interesting things about the cube if you learn it. So yeah, I hope you enjoyed it. I hope this video was useful, and if you have any questions or you want like a follow-up video that goes into any more detail, let me know and I'll consider doing that. Thanks for watching. Bye.